India may be approaching a point where its underwater advantage in the Indian Ocean starts slipping away. Pakistan has commissioned its first new Chinese-built Hangor-class AIP submarine, while China continues expanding one of the world's largest submarine fleets. India's answer is Project 75I, 6 advanced conventional submarines costing roughly $8 to $10 billion. But even if New Delhi approves the deal now, the first submarine could take about 7 years to arrive. In an undersea race, 7 years is a very long time. India already faces a force structure problem. Its 6 Kalvari-class submarines entered service without operational air-independent propulsion, or AIP. Older Sindhu Ghosh and Shishumar-class boats are approaching retirement. Project 75I aims to close that gap by pairing Germany's ThyssenKrupp Marine Systems, or TKMS, with Mazagon Dock shipbuilders. The proposed design comes from the Type 214 and 214NG lineage, with Indian adaptations and fuel cell AIP. The first revelation is that Pakistan has turned India's long-term submarine problem into an immediate one. Pakistan signed a 2015 agreement with China for 8 Hangor-class submarines. 4 are being built in China and 4 are planned for Karachi. PNS Hangor was commissioned on April 30th, 2026, and 3 more Chinese-built boats are expected to enter service between late 2026 and mid-2027. The roughly 2,800-ton Hangor-class uses Stirling cycle AIP. That lets a conventional submarine remain underwater far longer without repeatedly snorkeling to recharge batteries. It can carry torpedoes and anti-ship missiles with potential compatibility with the Babur 3 cruise missile. Pakistan could eventually field around 8 to 11 AIP-equipped submarines when upgraded Agosta 90B boats are included. That complicates Indian calculations by enabling longer patrols and increasing the burden on anti-submarine warfare forces. And the challenge becomes much larger when Pakistan's fleet is placed inside China's expanding undersea strategy. That is the second revelation. India is not facing a single submarine competitor. China's submarine fleet stands at roughly 60 to 65 boats in 2026. With projections pointing toward about 70 by 2027 and around 80 by 2035. Chinese maritime activity across the Indian Ocean adds uncertainty because research and dual-use vessels can collect information about underwater geography and acoustic conditions. China's defense relationship with Pakistan also gives Islamabad modern submarine technology and industrial support. Fleet numbers can mislead because submarines need maintenance, refits, repairs, and crew training. If India's older submarines retire faster than new ones arrive, operational patrols could fall sharply. Project 75. I would not erase China's numerical advantage, but it could strengthen surveillance and sea denial. And that leads to the third revelation, the most important part of Project 75. I may not be the submarines themselves. It may be what India learns while building them. Traditional diesel-electric submarines periodically approach snorkeling depth to run diesel engines and recharge batteries. That creates opportunities for detection by aircraft, ships, drones, and other sensors. Fuel cell AIP can generate electricity while the submarine stays submerged. For India, that means stronger sea denial and intelligence gathering around strategic sea lanes. But AIP does not turn a conventional submarine into a nuclear submarine. These boats still lack nuclear submarines' speed and endurance. Their advantage comes from remaining quiet and difficult to detect. That makes technology transfer critical. Under the strategic partnership model, Mazagon Dock would build the submarines in India while TKMS provides design knowledge, manufacturing processes, training, and AIP-related expertise. Indigenous content should rise from about 45% in the first submarine towards 60% by the sixth. India wants engineering skills, suppliers, and maintenance expertise that can support submarines for decades. That is why the technology transfer assessment matters. If TKMS transfers enough knowledge, Project 75, I could support Project 76, India's planned indigenous conventional submarine program. If the transfer remains shallow, India could build the hulls domestically while still depending on foreign suppliers for critical upgrades and propulsion. And now comes the deadline that could determine whether the strategy succeeds. Commercial negotiations brought the program toward an estimated $8 to $10 billion. So the consequences stretch far beyond India. For Pakistan, Project 75 signals that New Delhi wants to prevent the Hangor fleet from creating a lasting advantage in the Arabian Sea. For China, it shows India is strengthening the underwater shield around its maritime approaches and critical sea lanes. For the wider Indian Ocean, the program could intensify undersea competition. For India, however, the bigger prize is strategic autonomy, the ability to design, build, maintain, and eventually upgrade advanced submarines without permanent foreign dependence. But there is a paradox. The longer India waits, the longer it depends on an aging fleet. Yet rushing it without meaningful technology transfer could create another dependency for decades. Project 75 is therefore a race against both time and technology. India needs new submarines before its existing force contracts too sharply, but it also needs to turn those submarines into a foundation for domestic capability. The question is whether India can approve the deal, build the first submarine on schedule, and absorb enough technology to make the next generation genuinely Indian. There is also a wider industrial dimension to this race. Submarines are not weapons that India can simply purchase and forget. Each vessel requires specialized steel, precision welding, batteries, sonar systems, weapons, trained crews, maintenance facilities, and a supply chain capable of supporting the platform for decades. Every delay in production, therefore, creates more than a scheduling problem. It can break continuity in the workforce and force India to relearn complex manufacturing skills later. The 6 submarines also matter because they can create a bridge between today's imported technology and tomorrow's indigenous designs. If Indian engineers gain practical experience with propulsion, acoustic engineering, combat systems, and submarine integration, the country could eventually reduce the time and cost required to develop its own boats. That would give New Delhi something far more valuable than 6 additional hulls, a repeatable industrial capability. But the window is narrowing. Pakistan's Hangor program is already moving into operational service, while China continues producing submarines at a scale India cannot easily match. Every year of delay, therefore, increases the pressure on India's existing fleet. Project 75 is ultimately a test of whether India can convert urgency into capability before the underwater balance shifts too far. Because in the Indian Ocean, the decisive advantage may belong not to the Navy with the biggest submarine fleet, but to the country that can keep its submarines hidden, supplied, and multiplying faster than its rivals can find them.